All right, here we go, part 2. What equation do we use to relate temperature, mass, specific heat, and temperature change? Well, that equation is Q for heat equals mc delta T. We could also write it as Q, which is our heat, is equal to mc temperature final minus mc temperature initial. Solve that equation for mass, so mass is going to be Q divided by C delta T. Specific heat is going to be C is equal to Q over M delta T. Delta T is going to be Q over MC. And then if I wanted to find the final temperature, I'd go up here and play with this form. So I would say that Q plus MCTI divided by MC is equal to TF. And then if I wanted TI, I would say that MCTF minus Q divided by MC should equal TI. And all I did was my algebra there. What equations do we use for phase changes of water? Melts at 0 and vaporizes at 100. So if I want the heat needed to melt a chunk of ice, it's MHF. If I wanted to know the heat needed to boil water, I would say that it's MHB. HF is the heat of fusion. Heat of fusion. And that's the amount of heat needed to be applied to a gram of ice to melt it. And then HV is the heat of vaporization, and that's the amount of heat needed to be applied to a gram of water, boiling water, or water to make it turn into steam, I should say. Heat of vaporization. All right, going to clean that up and move on. So now here are some problems. You need to be able to show the work. So I'm going to heat aluminum that's contained in a roll of aluminum foil, and I want to take it from 25 to 350. So Q is equal to MC delta T. My mass is 500 grams. 4 significant digits. Specific heat capacity of the aluminum is 0.902 joules per gram degree Celsius. And my temperature change is 350 minus 25. So I'm going to take 500 grams, multiply it by the specific heat, 0.902 joules per gram degree Celsius, and then multiply that by the change in temperature to 325 degrees Celsius. And if I do that correctly, I'll have 3 significant digits in my answer, and my answer will be 147,000 joules. So there's that correct answer. Now I'm going to go on to the second one, number 16. Mass is 18.7 grams. And I want to change the temperature by 2.3 degrees Celsius. And I have 5.70 joules of heat energy added. And they want the C. So if Q equals MC delta T, then C is equal to Q divided by M delta T. So Q is 5.70 joules. M is 18.7 grams, 18.7 grams, and my delta T is 2.30. So I have 3 significant digits on all my numbers, so I want my answer to 3 significant digits, and I got 0.132 joules per gram degree Celsius. Okay. Number 17, a piece of silver is cooled, releasing 450 kilojoules of heat. So Q is 450 kilojoules. And it's going to go from 125 down to 10. So I'm going to change the temperature by 115. I'm looking for the mass. And the specific heat capacity is 0.24 joules per gram degree Celsius. So if I'm looking for the mass, I know the mass is equal to Q over C delta T. Q, they told me, was 450 kilojoules, but I can't leave it in kilojoules, so I've got to make a conversion happen. Well, 450 kilojoules, there's 1,000 joules for every 1 kilojoule. So that's 450,000 joules. 450,000 joules over C, which is 0.24 joules per gram degree Celsius. And my delta T was 115. So the mass of silver that I was working with, I got 16,000 joules. And I actually got more than that, but I only had 2 significant digits, so I'm going to record it as 16,000 grams. Right there where you can see it, 16,000 grams. Okay, clean those up. Okay, I believe we're on number 18 now. So the mass is 500 grams. Specific heat is 0.11. And I know that T initial is 25 degrees Celsius. They want to know T final when 330 grams of heat is applied. 330 calories is what I should have said of heat. So I had an equation a while ago that said the temperature final was equal to Q plus MC TI divided by MC. So Q is my 330 calories plus my M was 500 times my C, which was 0.11, times my initial temperature, which is 25, all divided by MC. M was 500 and C was 0.11. So I did the math across the top. And let me see if I've messed it up. And when I did that, I solved for my final temperature, and I got 31 degrees Celsius. Now I'm going to show you how I think it's easier to do that problem. I think it's much easier to say, okay, well, I had 330 calories, so there's my Q. It's equal to M, which is 500, C, which was 0.11, delta T, solve for delta T. When I did that, I got delta T to be 6 degrees Celsius, and I said, well, temperature final minus temperature initial is delta T. So temperature final minus 25 degrees Celsius is equal to 6 degrees Celsius. And then I got temperature final to be 31 degrees Celsius. Either way it'll work. I think this is easier algebraically, but that's your call. Okay? All right, let's move on to number 19. The heat of fusion for silver is 88.2 joules per gram. That's the heat of fusion. Now I want to melt 24 grams, so I'm going to say 24 grams times 88.2 joules for every gram I melt. So I need to have 2100 joules of heat. And I had 2 significant digits, so when I did the math, my answer actually came out to be 2,116.8, but I only wanted 2 significant digits, so I rounded it off. 29 says how much heat would be given off, so I'm looking for Q. And my heat of vaporization is 2260 joules per gram for water, and I have 8.6 grams, so Q is going to be my 8.6 grams times 2260 joules for every gram. So when I did that multiplication, I got an answer that was 19,436, but I only had two significant digits, so it should have been 19,000 joules. All right, move that and get on with the rest of this. We don't have much left to go. All right, so 21 says how much heat would be required to vaporize 100 grams of helium. If the heat of vaporization is 20.9 joules per gram, so Q is equal to MHV. M is 100. HB is 20.9. So I'm going to multiply 100 by 20.9. And when I did that, I got 2,090. And that was my answer. Now I got to convert joules to calories. Every calorie is 4.184 joules. So I'm going to divide 240 by 4.184. And when I did that, I got 57.36. But I wanted two significant digits. So I recorded it as 57 calories and moved on with my life. 70 calories to joules. Well, there's 4.184 joules for every 1 calorie. So I multiplied those together, and when I did, I got 292.88. But I want it in one significant digit, so I'm going to report it as 300. So pause it if you need to, but I'm going to clean it and move on. All right, 0.032 kilojoules. I want to go to joules. There's 1 kilojoule for every 1,000 joules. So that's going to be 32 joules. And then I want to convert calories to joules. So I'm going to do it up here. 900 calories has one significant digit. And I want to go to joules. There is 1 calorie for every 4.184 joules. So I'm going to multiply 9,000 by 4.184. I want one significant digit in my answer. So when I'm finished with that multiplication, I got 37,656. Too many digits. So I'm going to round that off to 40,000. There we go. All right, so I'm going to put this one up